Okay, so we're going to review some stuff like law of cosines. We're going to review a lot of stuff fairly quickly, but I think it'll help put a context on this whole area of triangles that we're doing today. Area of not right triangles, that'd be too easy. 1/2 base times height, done. But what if it's a not right triangle? There's an app for that. There's a formula for that. All right, so I'm going to do some review with you, and here's the first thing. You remember the 45, 45, 90 triangle? Would you please draw one like that and then label for me what the sides are? Like 1, 2, square root of 3 is something like that, except it's not that. 45, 45, 90, and then the 30, 60, 90. But start with 45, 45, 90 and put the numbers on it for the sides. And I know you don't know for sure. What if it's like 8, 9, and 17? It's got to be the right ratio. So we use the simplest numbers. And that means in both triangles, you use at least 1, 1. Because that'll make it the simplest it could possibly be. All right, would you please turn the triangle my way for the 45, 45, 90? I'll tell you if you're doing it right. Yes, would you please zoom in on just the 45, 45, 90 to start with? So much easier for me when I'm looking at all these papers. Yes, 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 yes. Everybody's doing that one right. It's 1, 1, and the square root of 2. This other one, however, a lot of people are going to do wrong because they are going to put the square root in the wrong place. Think about it carefully before you do it, and then would you please compare it? I'm already seeing 2 answers, and I see them different. So compare it with the kid next to you, and make sure your hypotenuse is compared properly. See if you're the same. Compare it with the kid. I usually pair you with rows 1 and 2, 3 and 4, etc. I'll pause while you put in those groups. What is the right answer for this? 1 goes on the shortest side. That's a great way to start. Then what? You got it in the last one? All right, good. Now, why are these handy? Because you don't need a calculator to do trig if you can break it down into 30, 60, 90s. And a lot of the problems on the ACT test are going to be based on 30, 60, 90s because they don't want to make the calculator be like all powerful. And so what if they made this A and they made this, what would that have to be then? 2, is it 2A? Is that right? Okay. And what would they have to make the last one then? A times the square root of 3. Do you get how that would foil kids who were like trying to just type the numbers into your calculator because you have a variable there? Okay. My point is that they sometimes want to see, can you handle these right triangles without a calc? So, for example, right now, would you please calculate for me 2 things? Cosine of 45 and sine of 60. Cosine of 45 and sine of 60. No calculator. That's the point. I have to put it all the way away because we are going to use calculators later. But if you have a decimal answer, we'll all know you cheated. Because right now we're doing it from these triangles. Cosine of 45 and sine of 60. If you forgot how this works, ask the kid sitting next to you. It's all about setting up a trig equation. It would look something like this. Cosine of 45 is equal to cosine is CAH, SOHCAHTOA, right? So adjacent over hypotenuse. The adjacent one, well, it doesn't matter which 45 you use because the adjacent one either way is 1 over the square root of 2. Raise your hand if you had that one right. Okay, good. And then the second part of it, sine 60. Let's use the dice of destiny. Just tell me who I should call on. We have a row 3, last person, Mr. B. Square root of 3 over 2. Raise your hand if you had the same thing as he had. That's almost everybody. Good. Okay. So that's your basic right triangle trig. But what if you don't have a right triangle? That's what we've been working on this whole time. And we learned a bunch of formulas, one of which was the law of sines. I would like you right now to use the law of sines to prove But that angle, we all know it's 30. But how would you use the law of sines to figure out that angle if I hadn't known that this was a right triangle for sure? So you can't use the fact it's a right triangle. How would you use law of sines to figure out the question mark right there? Well, first thing you better do is write down the formula for the law of sines, and then try to figure out, how could you figure out that question mark? I know the answer is 30. My question is, how could you use law of sines to find that? In a moment, I'm going to ask you to compare the law of sines that you wrote down to the other kid. So please write down the formula for the law of sines. I think that might be all that some of you can do. Some of you might not know how to do the rest. I'll pause for a second when we give that a try. Okay, at this point, would you please turn and compare the law of sines with the kid that I paired you with? Just the law of sines. Okay, if you had them upside down from the other person, does that make you wrong? The law of sines can be written upside down. I'm curious, how many of you did it the way I did it? Okay, how many of you did it upside down from that? You put sine on top and a little a on the bottom. Okay, it's an okay, by the way, just so you know, it's totally okay to have this reversed. Sine of big A over little a equals sine of big B over little b, etc. Fine to be upside down, it'll work just fine. It's just you can't reverse only one part of it. You know what I mean? We couldn't take this and then reverse these two only. That won't work. Okay, did I give you enough info? Yeah, there's lots of info in this problem. I already know, I know all three sides. I knew this and this and this. And then, how do I know which one the question mark is? Is it A, B, or C? It can be anything I pick it to be, can it? Okay, so you might go back to the old, well, this has got to be C because it's a right triangle. No, it's not. I said in this problem, we don't know for sure it's a right triangle. All right, so then, given that, we should use the 60 across from, well, what did you guys pick? Did you guys pick that to be C or A or B? How many of you used the question mark was like C? Raise your hand if you use C for your question mark. How about B for your question mark? How about A for your question mark? It's about half and half between A and B. I'm going with A. If A is going to be my question mark, then it's the 1 going across from that is that. So 1 over sine of A equals, and then B, what do we have to use for this? Square root of 3 has to be the one we use. Why? Because we got an angle across from that. That's what makes this a good problem to use law of sines on, because I got a side and an angle across from it. Do you get that that pair is what makes the law of sines work? If you don't have that, like for instance, if I just give you the three sides, if I just give you this and this and this, do you get it can't give me the angles? But there's something that can. If I give you all three sides, there's a different formula that would solve that. Which one? Law of cosines. Would you please write down the law of cosines now? And I will tell you three sides, and I'll let you figure out what the angles must be. Would you please compare the law of cosines that you're trying to recall? And I'll give you a hint. It starts with a squared. Try to write down the law of cosines and compare it with the person that I have paired you with. Pause while you do that. The angles. What was the law of cosines? The law of cosines was a squared plus b squared equals c squared, kind of, except you throw in something else. What? 2ab sine, sorry, that would have been the law of sines, cosine c. This little factor right here is what makes it different than the Pythagorean theorem. And now I'm going to use this for this triangle that I'm about to give you. This is 8, this is 7, and this is 9. Is it a right triangle? No, because it's not a Pythagorean triple. As in 7 squared plus 8 squared doesn't equal 9 squared. You probably memorized the one that works. 3, 4, 5, and any multiple of that. Like 3, 4, 5 would be like 6 and 8 and 10. Okay, so 3, 4, 5 triangles are a Pythagorean triple. What's another common combo? 5, 12, 13. It comes up a lot. You should have that one memorized. 5, 12, 13 goes together. 5 squared plus 12 squared equals 13 squared. And of course, any multiple of that. But this does not make one of those Pythagorean triples, so I can use this rule. But wait a minute, you're saying to yourself, you haven't told me any angles. Right, so you're going to leave this angle, it's the only one angle in the whole thing, you'll leave that as a big C, and you'll be able to solve. Take a moment. And just so we're all the same, who's using, you don't have to be, but who's using what for what? Is this A, B, or C? How many of you are using that as A? 8 is the A. How many of you are using the 7 was the A? And how about the 9 is the A? Nobody used the 9 as the A? Okay, fine. You know what? I'm not going to make you change your mind. It actually worked no matter what you do. I'm going to ask you then for the angles, not as called A, B, and C. I'll ask you for the green angle, the red angle, and the black angle. I'll just ask you what was the green angle, and then I don't care what you called it, A, B, or C. Okay? Because again, it doesn't matter. You can pick any letter you want. Any of these to be any letter. Would you please solve for the red and the green and the black angle, and then compare with the kids sitting next to you. Just reviewing the law of cosines at this point. And you got me, so I owe you. Okay, so 12, back to this one, 48.2, and then I just figured out that I called on the wrong person, but then it got really confusing. What's this red one? Guy in the Patriots shirt. Can anybody verify that one? Okay, good. Now the guy I was actually calling on in the back row in the hat, which you should now remove, please. Thank you. Go ahead. 58.4. All right, 58.4. Can anybody verify that one? Good. We could do it by process of elimination with a squared plus b squared equals, no, with 180 is the total, sorry. But anyway, these three angles can easily be found using this. All right. In case anybody's completely lost on how you do that, you're going to put in all of the A and the B and the C. And there, and there, and there. Everything goes in there. And at the end, you are solving for the cosine of C, and you take the inverse cosine at the very end of the problem. And if you want to know more about that, watch one of my previous lessons on using the law of cosines. All right, so that leads us to the new thing, which is if we had a triangle that wasn't a right triangle, I know this looks a lot like a right triangle, let's say it's close, but not exactly a right triangle, then how could you find the area of a triangle that was not a right triangle? Anybody have it memorized already? Because you just knew this before? Well, cool, then everybody's going to learn something. All right, any guesses what things would probably be in the formula? Yes, sir. You absolutely can. In fact, on the ACT test, they give this same problem. And then if you're going to do it this way, you can find it with all kinds of other ways. You can find this area, but there's a short, sweet little formula for it. And that saves you a ton of time. And that's why it's, again, a good thing to memorize. This one's actually pretty useful for the ACT test because you'll be like, wait a minute, trick question. It's a right, not a right triangle, and they want me to do the area of it. Oh my gosh. And they think, okay, now I can do this really complicated, divide it up into triangles thing. It works. But there's a formula, area equals, who has a guess on what's in it? I bet you got some good instincts. What do you think? I agree. 1/2 should be in it because that's in the other formula, right? And then we usually call the sides of these A, B, and C. Come on, take a shot. I bet you honestly you could guess your way to most of this formula. A and a B. Okay, there we go. And then the last part, what do you think's gotta be in this thing? C. Okay, good. And what? And a sine, a cosine, or a tangent. Yes, I'm getting all three functions from people. I know you don't know which one, but I'll give you this. All of them really are based on one function. There's one function that's sort of the mother function, so to speak. Yes, I know this sounds naughty. We'll get to it. Anyway, so the mother of all the functions that are like this, the trig functions, is sine. Because the cosine is just sine except shifted over a little bit. And tangent is actually just sine divided by cosine. So really, it all comes down to sine because the cosine you could have got from the sine. So sine is the base of all of them. And so it shouldn't be too surprising that sine is in this formula. And you already told me there's one thing missing. It'd probably be logical to have in there. Sine of C. Good. Now, how does that work for a right triangle? Because, wait a minute, didn't you say, Mr. Server, that this is used for not right triangles? Don't you think it would also work for a right triangle? Like, do you think it doesn't work for right triangles? No, it actually does. So let's use one we actually know that's a right triangle. Would you agree that the 30, 60, 90 triangle is a right triangle? Okay, and would you agree that if this side here was, let's say, 3, that we can figure out all the other sides using that little pattern? Do you get that this side is double this side, and so therefore what? That's got to be 6. And therefore the last one, which has got to have the square root of 3 in it somehow. How many times bigger is this than the normal one? 3 times bigger, so you go 3 root 3. Wouldn't you agree this should normally be 1, 2, and the square root of 3? But it's 3 times bigger than that? Does that make sense to you? All right, so now I know all my sides, I know my angles, and you might be saying, well, this is really dumb to do it this way because couldn't you just go base times height divide by 2 on this one? Yeah, you could. In fact, let's do that first. Everybody use no calculator. Use the base. Oops, that didn't help. There we go. Yeah, use the base and times it by the height and then just divide by 2. Just use old school 1/2 base times height. Everybody do that, please. And yes, your answer will have a square root of 3 in it, and it's okay. One half. What's the base? 3 root 3 times the height, which is 3. So then just multiply this all out, and that becomes, let's see, 1/2 times 3 is 3 halves, times 3 is 9 halves. So it'd be 9 root 3 over 2. Do you get what I just did there? I just multiplied this out, and I got that. So I know that's my answer. I'm not using decimals here. I'm not using cheating and using a calculator. I will in a moment. Okay. So what's my point? My point is to show you that this works on a right triangle where you already know the answer should be this. Let's see if it comes out the same using this whole 1/2 AB sine C thing. All right. Now this is important. Can I pick anything to be A and B and C? This only works when you use a sandwich. Like for instance, that and that can be A and B. And if that and that are A and B, do you get that that has to be C? See what I mean? It has to be 2 sides and an angle. It's like angle, side, angle. No. Side, angle, side. Okay? Like I got those 3 as a combo. Do you get if I did those 2 along with this one, this formula would not work? Okay, good. It's got to be 2 sides and the angle goes with them. What two sides did we use? This and this, right? And therefore, that's the angle that we have to use. And again, in the old, like when you were doing this the first time, you couldn't ever do sine of 90. That wasn't like allowed. Now you can. So it's 1/2 times A, which is, well, let's make that the 3√3. B, which is, let's make that the 3. And wait a minute, isn't that the exact same thing we had before? How can we then multiply it by sine of 90? Because then sine of 90 happens to equal exactly what? 1. That's why this works. For right triangles, too. Okay, so we know that the same answer, because now sine of 90, if you don't know it off the top of your head, which most people wouldn't, you probably just assumed it must equal 1. It does. If you type it in the calculator, sine 90, it'll equal 1. What if a kid next to you were to type in sine 90 and theirs didn't equal 1? They're in radians. Very good. And it happens all the time. People really got to check that before you start your ACT test. Okay, so this formula that you just learned right here is the last one you need for this big test. And why aren't we just like taking the test in 2 days from now instead of 3 days from now then? I mean, we could have a review day tomorrow and then the test on Thursday, because there's still a lot more that you can do with these problems to make them hard. Like, do you think we're always just going to give you a triangle and say, here's 8 and here's 7 and this angle's 35? If we did, you should be really happy because that sets up perfectly. But of course, we're not going to make them set up perfectly. We're going to have to make you work for it. Let's just see how easy it would be, though. Let's complete this triangle with some unknown side here. Doesn't even matter, does it? What's the area of that triangle? Figure it out using the new formula I just gave you. That is an easy one. Try the easy one first. Got the formula memorized yet? I see a couple people with blank stares, so somebody help me. What's the formula for this thing? Area equals what? 1/2 AB sine C. Does not matter whether you pick 7 or 8 to be A or B. It does not matter. You can use the calculator because I don't expect you to know sine of 35 degrees. To get if that was a 45 degrees, then I could expect you to know what sine of 45 is. You might be like, but it's not a right triangle. Doesn't matter. If I make this 45 degrees, you should be able to do it without a calculator. Because all it boils down to is you got to know what the sine of 45 is. Not that this is a right triangle. The question is, what's the sine of 45? So you go and make a right triangle. That's got 1 square root of 2, and you go sine. Sine is opposite of hypotenuse, so 1 over square root of 2. And you could put that in for this, if it had been a 45-degree angle. My point is just, remember those triangles. They're important. Okay, so back to this. What did you get when you typed in everything? Or have you yet? Anybody verify 16.06? Okay, good. From there, it's just typing numbers in. This is a 7 and this is an 8, and you can see why it doesn't matter if I reverse them, because 7 times 8 or 8 times 7, same thing. And then sine of 35. What did you say, 16 point what? All right, and if this had been in meters, do you get that that means the answer's in what? For area, meters squared. Area is rho squared. Okay. Now, I didn't say it was in meters. I'm just saying, just be careful of that, that if we give you units on the test, you'll have to give us units for your answers. All right, so how could we make this more complicated? What if we gave you those two sides, but this angle? Do you get that you can't do it right away? Can't use this formula yet until you have two sides and the angle between them. But can't you figure out the angle between them? Yeah, you can, because you have a setup for which formula is better. Law of sines, because you got the one across from, you got an angle and the side across from it. That's a law of sines setup. Would you please use law of sines to figure out this new question mark? Because it won't be what it was last time. Figure out the angle and then figure out the area of this triangle. using law of sines. You're figuring out the question mark. Pause for a second while you do that. All right, so on this problem, you can't just jump into 1/2 AB sine C. So instead, what rule did you have to use? Law of sines. Good. Law of sines, because we have this and this going together. And what did you get for the question mark when you used law of sines? 25? 30.1? Okay, well, maybe I should show how to do this. Okay. Sine of 35 would go with, now I'm going to put the sign on top and the number on the bottom. Is that going to bother you? You can do it both ways. All right. And then the number that goes on the bottom is an 8 equals, and then we'd go with, well, we don't know. This is the one we want to figure out, right? Okay, but we don't know this other side over here. So how am I going to set this up? I have to solve for this angle first. Aha! Okay, so then I can still say sine of 35 goes with the 8. Nothing wrong there. But now I'm going to go sine of unknown angle, red question mark, over 7. And then I'll find the red question mark angle first. Maybe I should call these different letters instead of red question mark. Let me call this like Q. So I'm signing sine of Q. And then we'll make this P. And eventually I'll want to know what P is. All right, so this would tell me Q by doing cross multiplying. This all times by 7 would also work. And then I do inverse sine of that. And what did this angle come out to be first, please? Can anybody verify 30.12 for that angle? Okay, good. And if that angle is 30.12 and that angle is 35, I can just take 180 minus 35 minus 30.12. And what did that come up to? 114? All right. Do you get that I didn't draw this picture very well? Isn't that, you know, it's a safe statement, right? That obviously it wasn't drawn very well, so it's okay. But do you remember that you can't trust necessarily that the pictures are drawn to scale? That's really important in this unit. And it's also true on the ACT. They say somewhere in the fine print, don't trust that pictures are drawn to scale. All it takes is a copier to be off by a little bit. And you can bet some lawyer would say, you said on the ACT it was a 35-degree angle, but it's actually 36 degrees on the paper, because when they copied it, it got, you know, off a little bit. So anyway, the pictures aren't always drawn perfectly. This was drawn terribly. All right, but it comes out to 114. Raise your hand if you got that without any help from me. Okay, good. That's the new thing for today. Now let's actually go find some homework problems. Since I'll tell you a couple you can skip. I feel like with first day back from a long weekend, we can probably cut it down a smidge. Well, let's just look at this green problem real quick first. Do you get if they gave you all the sides, you cannot just jump right in and use 1/2 AB sine C? Because you don't know the angle yet. Could you use law of sines to find this? No. Okay, you can use the law of cosines. Yes, you can't use the law of sines though. And what we also can't use is 1/2 AB sine C because we don't have an angle yet. So law of cosines would be how you'd solve this one. And let's say you'd find this red angle, and then you could find that's A and B, and that could be sine C. So we just have to find one angle by using law of cosines. All right, good enough on that. Let's move on to the actual homework. And day one starts here. It's orange. And in this problem, let me just use some logic. Remember I said it was not drawn to scale, but make it, if you're picking, make it look at least logical. Like that, you're going to put that as 12 degrees? No. You probably want to put it over further and put the 12 degrees here. All right, you may want to listen to which ones you can skip. All right, you have to do number 1 and 2. And you may skip the unknown numbered problem here. This doesn't have a number. It's seafoam green. You may skip that one. And you may also skip the very last one of the assignment for today, which is that one, a 6-minute or a 4-minute question. That will cut your assignment down to a more reasonable size. For tomorrow, make sure you have it done. And you'll be practicing the new formula. And that's all